Let's talk flour power. Not the fluffy white stuff, but the muscle behind it. See, before wheat becomes bread, it needs serious grinding. That's where our buddy, the pinion gear, steps in. Imagine a giant metal gear. We're talking heavy-duty, built-to-last kind of gear. This ain't no plastic toy. This is the heart of a flour mill. These gears transfer power from the motor to the grinding rollers. Without them, the rollers wouldn't roll, the wheat wouldn't grind, and we'd all be out of bread. And nobody wants a world without sandwiches. Trust me, I've been there. It ain't pretty. The bigger the mill, the bigger the gears. We're talking massive pieces of metal, some weighing several tons. Making these gears is a serious job. It's a blend of brute force and meticulous precision. You need brawn and brains to get it done right. Let's dive into how these monster gears are made, from raw steel to finished product. We're going behind the scenes, folks. Get ready to get your hands dirty. First things first, you need the right stuff. And by stuff, I mean steel. Not just any steel, though. We're talking about high-quality alloys, chosen for their strength and durability. These gears are going to be under a lot of stress, so they gotta be tough. Think of a blacksmith hammering a horseshoe. Same principle here, but on a much larger scale. The steel is heated to extreme temperatures, turning it into a glowing orange blob. Then, using massive hammers or presses, it's pounded into the basic shape of a gear. This process, called forging, does more than just shape the metal. It actually changes the internal structure, making it denser and stronger. It's like taking a bunch of loose threads and weaving them into a tight, unbreakable rope. The forging process is hot, loud, and dangerous. But it's also mesmerizing. To see a massive chunk of metal molded like clay is truly awe-inspiring. It's a testament to the skill and craftsmanship of the people who do this work. Once the gear is forged, it's still a long way from finished. Now it's time for the machinists to work their magic. This is where precision is key. We're talking about tolerances measured in thousandths of an inch. One tiny mistake and the whole gear could be ruined. Using giant lathes, milling machines, and other specialized tools, these skilled workers shave away excess metal. They carve out the teeth of the gear, each one perfectly spaced and angled. It's like sculpting, but with steel instead of marble. This process can take days, even weeks, depending on the size and complexity of the gear. It's a delicate dance between man and machine, requiring a steady hand and a keen eye. But the end result is a thing of beauty, a perfectly formed gear ready to do its job. But wait, there's more. Before a pinion gear can leave the factory, it goes through rigorous quality control. Every step of the process, from the initial selection of the steel to the final machining, is carefully inspected. We're talking X-rays, ultrasonic testing, the works. These gears are going to be working hard, so there's no room for error. Think about it. A single faulty gear could shut down an entire mill, costing a company thousands of dollars in lost production. That's why quality control is so important. Once a gear passes all the tests, it's ready to be shipped out. It might be headed to a flour mill down the road or one halfway around the world. But no matter where it ends up, you can be sure of one thing. It's a quality piece of equipment built to last, and that's something